Good afternoon. Hello, everyone. So once again, welcome to QA Systems and Inland Software's webinar. My name is Christoph Horvat. I'm on Inland's marketing team, and I will be moderating today's Expert Talk session. So first, let me introduce our hosts today. From QA Systems, we have Matt Davis on the webinar. Matt is a quality assurance and testing expert, and he's the managing director of QA Systems Limited. He's going to talk about automating unit testing for existing code. And in his presentation, Matt will cover automated test case generation, test execution, and the topics of traceability and coverage. On the Intland side, we have Adam Shomoriai, a pre-sales consultant and a recent hire by Intland. And in today's webinar, Adam will show us how to manage requirements in Codebeamer ALM. In the live demo, he will also cover test case generation and traceability analysis. So let's see what we have on the agenda today. First off, I will quickly introduce Intland Software and Codebeamer ALM so that those coming in through QA Systems who might not be familiar with us understand who we are and what it is that we do. This should also help you understand the value of this integration between QA Systems Cantata and our own Codebeamer ALM that we're going to be demonstrating today. Then I will talk about how Codebeamer ALM supports safety critical development and how it helps reduce the time and cost of compliance in regulated industries. This will be followed by a QA Systems presentation. Matt will first talk about the challenges of testing and compliance, and then he will extensively cover the topics of test automation, test coverage, and traceability. After this, we'll move on to live demonstrations of both Codebeamer and Cantata. The demo will also showcase the seamless integration between these two tools to help you understand how automated testing with these platforms works out in practice. After the demo, we'll have some time for a questions and answer session. Please note that your questions are welcome anytime during the webinar. So just use the questions box on your GoToWebinar control panel. And at the end, we will go through all those questions and answer them as best we can. In case we run out of time, which has happened before, it's fine. We'll just take it offline and we will provide answers by email. So don't hold back. Feel free to ask your questions anytime during or even after the webinar. Because another important thing to note is that a recording of today's session will be sent to you after the webinar, so you'll find it in your inbox. And feel free to ask even afterwards. Right, so before we start, let me give you a super quick introduction to Intland Software. The company was founded in 1998, and like QS Systems, we are based in Stuttgart. We also have an office in the US and are represented by partners and resellers worldwide. On this slide, you can see a short list of some of our customers to give you an idea of the kind of companies that use Codebeamer. As you can see, our tool is widely used by players in safety critical and high-tech product development. Now, at this point, those not familiar with Codebeamer might be wondering just what this tool is. So let me give you a quick rundown of the platform. In short, Codebeamer is a holistically integrated application lifecycle management tool with features that cover the entire lifecycle. It's an all-in-one platform which has many benefits over working with single-point tools. Lifecycle-wide traceability is one key advantage, but for developers operating in highly regulated industries, Codebeamer offers a variety of powerful features that I'm going to tell you more about in a minute. For now, what's important is that Codebeamer is holistically integrated, meaning that it's not an integration of standalone previously purchased or developed components. It was built organically integrated from the ground up. Codebeamer is also a TÜV trusted tool, which is certified to support compliance with ISO 26262 and the general standard IEC 61508. The platform works well with any development methodology, whether you're working with Waterfall, Agile, or Scaled Agile. It is highly scalable and has strong quality assurance capabilities, which all make it a good fit for regulated development. So in short, Codebeamer basically helps you develop better products faster. And on the next slide, we're going to take a look at how exactly it's able to do that. So this illustration shows you the main components of our system. First off, it's important to note that, as I said, Codebeamer was built organically integrated from the ground up. It uses a single central repository to store all your lifecycle data. And this means that traceability is guaranteed from the product idea all the way through to release and operations. Codebeamer also provides collaborative features throughout the entire lifecycle, and it enables real-time access to information for all stakeholders throughout the entire process of development. It's a single central platform that lets you manage requirements, development, testing, and release, and it also offers strong DevOps capabilities, further reinforcing its focus on quality. Everything in Codebeamer, as you will see, is versioned, traced, and fully controlled. Now, as I said before, Codebeamer offers a range of features and capabilities for safety-critical developers. The fact that it relies on a single central repository means that gapless end-to-end traceability is guaranteed, but the system also automatically records a full change history on each and every work item. This helps ensure that no change goes unnoticed, and that it also helps reporting and preparing for compliance audits. We also have offer collaborative features that help access control, project and task management, and agile development while maintaining compliance. Due to its advanced workflow engine, the platform enables strict process control throughout the entire lifecycle. Reporting features help you filter and visualize any and all of your lifecycle data. As you will see, Intland Software also offers pre-configured templates for companies involved in the development of medical devices, automotive embedded systems, and avionics products. These templates help you implement continuous compliance and save you time, effort, and costs in these complex development processes. The templates are pre-configured with artifacts, workflows, and reports to simplify compliance. Now, all of this will be way easier to understand once you see how Codebeamer ALM actually works. So before I pass on presenting rights to Matt, let me just give you a few poll questions. I'd like to ask you a few very short questions, which will help. Basically, these will give us an idea about your development environment, and they should help us better understand how you work and how we can better help you. First one, very simple. We'd like to know the size of your teams that you're working with. That's perfect, thank you. We only have 4 more questions. It's going to take us about a minute. Next one should be relatively easy to answer. It's about the major challenges that you're facing in your development right now. Thank you. The next one's about your tool set, whether you are currently using an automated unit or integration testing platform. Thank you. And another interesting one, this one's about safety standards you're currently working towards, that you're working to comply with. That's great, thank you. And there's one last question before we head on to QA Systems presentation, whether there is an ongoing evaluation of application lifecycle management tools at your company right now. All right, thanks a lot for your answers. And now we'll be passing on presenting rights to Matt.
Thank you, Christoph. I hope I'm being heard okay, and good day to everybody. So my name is Matt Davis, and I'm going to talk about automated compliance testing with Kantata, and in particular with a focus on automated unit testing for existing code. So start straight in. Where is Kantata? Where does it fit in your software development lifecycle? Well, down the left-hand side of a rather traditional-looking V model, we have design decomposition from system requirements through to lowest level requirements may be captured in a unit design and implementation in code. And the first thing you might want to do is, does the code do what it should do? In other words, is it meeting those things? For that, you really need to exercise that code, and that requires dynamic testing proof, and this is where Kantata comes in. So Kantata is predominantly focused for unit and integration testing, but also supports system and acceptance testing as well. Second question you might want to ask is, how much of the code have I tested? Not just does it do what it's supposed to do, but have I tested all of it? And for that, we use code coverage requirements. And finally, of course, is are all the requirements actually met by the tests and verified by the tests? So that's about requirements traceability. So have all the requirements been verified and all those tests pass? So Cantata provides capabilities for all of those, and that's where it fits in the software development cycle. However, if you're dealing with compliance for individual coding standards or individual development standards, you'll find that there are several significant technical challenges. So in our little QA systems car, you see those flashing up as road signs, and I'm going to touch on each of those. And of course, show you some of our Cantata certified solutions when we get to the demonstration. So the first one is, will it work with what I have? I'm using a tool, it's a specialist tool, it's going to work with everything else in my tool chain integrated to that and running on embedded targets, because a lot of high integrity code is going to be running on those embedded platforms. So the first thing to say is yes, Cantata is integrated with your environment. It can be deployed to literally any target. There are unlimited target deployment capabilities built into the tool for end users to use. You can have support from resellers or QA systems directly to do those. And you can also control which configurations you are running with if your software is running on multiple configurations. In addition to the hardware or the environment, there are also other tools in your chain. So it might be you are doing static analysis. QA Systems also resells the QAC++ set of static analysis tools, but we also work with other tools in your tool chain, like your continuous integration, software configuration management, bug tracking, whether it's through Jenkins, Jira, Git, etc. And of course, while you're developing code, you want to be able to work in the same environment for when you are testing it. So that means integrating with IDEs. And of course, we do that too. One of the more interesting technical challenges for unit and integration testing is being able to isolate that software from the rest of the system. So it's not a whole system, it's a unit or an integration area. And you're then looking at what happens when those function calls occur, whether you are effectively breaking the chain of dependency over that call interface boundary. And Cantata has a number of capabilities here to offer you the choice to either control through simulation or to control through interception. And they're all automatically generated. So we generate automatically simulations, what some people might call stubs, mocks, fakes, dummies, etc. The terminology we have in our tool are stubs and isolates. But we can also intercept and use the real called object. And for this, we call that wrapping. So whether those things are included in your build or not included in your build, you get all of the control to be able to set and check things, as well as the ability to decide whether you isolate them or include them in an integration run. And that also covers things like being able to do different things each time calls are made. So to check all the parameters passed over the interface, do different programmable instances on each call, and control which calls in what order are used in individual test cases. Code coverage, the measure of how much you have tested the code, really does need to be integrated into your test framework. If you do it manually afterwards, it's a heck of a wasted time and effort. So it's not just being integrated, but also what it can do for you in terms of diagnostics. Cantata provides pinpoint analysis, but first of all, it makes it simple. Its predefined set of standard specific coverage rule sets means you can simply select the standard you're working to, the SIL that you're working for, and it will pre-populate all the necessary metrics, gathering and recording information for you. It can be used with a Cantata test or with anything else that drives the code, and you can integrate the two for a complete picture. But it also provides very powerful drill down views, filters, and reports. From a complete system view with metrics per node through a tree, right down to individual syntax on a line, as you can see in this in the slide picture. Cantata also provides automatic test case coverage optimization, which is very powerful when you don't know which data combinations of vectors to use, or when you are simply trying to optimize the set to a minimum amount. But the real power is about automation. This is the biggest technical challenge with any tool. What can be automated and how much can it do for you? Well, Cantata can do a lot in very flexible ways. First of all, There are lots of different styles of testing, whether it's unit isolation, procedural, object-oriented, black box, white box, etc. And Cantata has flexible testing constructs for all of these types. But the one I'm going to concentrate on today is something we call AutoTest, which means reading the code and generating tests from it directly. It also, alongside the tests, produces all the necessary hierarchy of makefiles for regression testing automatically. So why would somebody use this automatic test vector generation? Well, firstly, because you can generate the scripts really quickly, the test cases really quickly, and you can use them in different modes. So isolation unit testing or cluster integration testing. And it's not just creating test inputs, but also what the expected behavior outputs are. So it's verifying the inputs, the outputs, and all the behavior throughout the call sequence and call ordering. It allows you to plug gaps in hard to design test vectors. And what I mean by this is it might be simple to come up with the basic behavior of what the software should do, but if you don't know how to drive the software down all the edge conditions, that's where the hard work comes in creating tests, and it can add that automatically. The big power of auto test vector generation, though, is making it understandable for easy requirements tracing. And that's a capability in Cantata's AutoTest, which produces test descriptions that explain the path through the code that they are exercising. And that generation not only creates runnable tests, but it also tells you if there's any problems in the code that couldn't be it will generate and identify testability issues like type truncation, uninitialized data, and so on. And of course, fundamentally, it reduces your reliance on functional level tests. If you can do them automatically, you can supplement or replace some of your system level functional tests being rerun all of the time, because unit tests are just machine time to rebuild and run. So a suite of passing unit tests can also be more thorough in terms of a safety net for your regression testing on code that already works. Particularly powerful if you're doing continuous integration. So how does it work? Well, basically, it's highly configurable, and we automatically can generate from the command line or the UI test cases for suites of scripts or for test cases to plug gaps. It's basically designed to generate all the paths through the code. How do we calculate that? Depends on what metric you want to achieve. So if you are looking at something like the highest integrity level in automotive or avionics, you would be looking for MCDC coverage, modified condition decision coverage. For lower cells, less requirements, therefore less test cases. And the style of testing, whether it is black box or white box, can also be controlled with maintainably described test vectors, as I mentioned. There's a diagram up on screen, so you can look at that at your leisure afterwards, that the flow of how this all works together. But basically, it reads the code, generates tests and scripts to run them. When they're run, it produces the results for you to see. So, talking of results, how do I deal with the fact that I've got lots of engineers writing lots of tests on different environments? It's about centralizing for control and about enabling teams to work together. So for this, we have an add-on for Cantata. Because it's a desktop product, this creates a server architecture with all of the data centrally grouped and stored. And that means that you can aggregate all of the tests from all of the different machines and aggregate coverage results across all the different runs, with history and trending and lots of powerful advanced filtering to be able to differentiate between different runs. So it might be the same code executing on different target platforms, for example, or even looking at that over a time frame selection. And of course, it has direct link to ALM tools like Codebeamer, allowing you to drill down into reports and details from things that you are looking at in terms of your traceability and requirements management. And that requirements traceability is the crux of the integration with Codebeamer and Cantata. It's about maintaining bidirectional requirements traceability, but integrated with your existing requirements management tool. And so for us, that means we're not going to try and do this. There are great tools like Codebeamer for us to do it with. For bidirectional traceability, you have your requirements. Those three circles are indicating requirements in Codebeamer, and you export those. Now, we use a Recif interchange to export that data. I'll come on and show you how that works in the future. Cantata stores that information locally on a server, allowing you to relate that information from the requirement to the test. So the first thing you might want to do is generate the tests automatically. then link those tests to requirements using a nice drag and drop assignment capability we'll show in the demo, and then export those, which is actually done automatically to Codebeamer with all the bidirectional links, all the test run results and status, what's known as the conclusion in Codebeamer, the code coverage information obtained, and of course, being able to visualize in Codebeamer the requirements traceability coverage, so that you have full traceability evidence and requirements coverage all in the one location that you need it. So in terms of the automation process, what that means fundamentally is automating the test vector generation so that you are able to run tests, create them automatically right up to MCDC coverage with all those hard to reach out conditions. That is not just the inputs, but all the expected behavior too, actual outputs and parameters and call orders, automatically executing those on a continuous run, and of course providing an efficient traceability and coverage mapping, which is a combination of being able to see the information in Cantata and in Codebeamer, where you store it and use it as your traceability test evidence. Or with the certified tool, right up to ASIL, all the highest level of integrity for all of the safety standards. So Christoph, that's the presentation done. I should pass over to
Adam, please.
Adam, or you switch that?
I just did. Thanks a lot, Matt. And Adam, it's over to you.
Okay, thank you, Matt. So my name is, hello everyone, my name is Adam Somodé, and I'm going to show you the basic functionality of Codebeamer, focusing on requirements and test generation, but focus will be on the second demonstration when Matt is going to show you how to generate and automate tests and connect back to the requirements. Okay, so some of you might already know that, but I think it's important to highlight that Codebeamer is a 100% browser-based solution, which can be hosted on-premise or as a cloud-based solution. And today we are going to use a cloud instance, which is running on an Amazon cloud server. So now we are here in the login page, and if I click on login, being redirected to the project browser, which you can see here. And here I can see all the projects that I'm the member of, and each item represents a fully pre-configured project covering one specific life cycle, which can be which can support a V model, agile, or a hybrid methodology. And on the left-hand side, you can see the projects grouped into a category, and here in the middle, as I just mentioned, we can see the recently open project. And today, I'm going to open up this pre-configured project with an automotive content. And the very first page, when I enter a Codebeamer project, is the Wiki page of that particular project. And here in the Wiki, you can define and maintain, let's say, a knowledge base for your stakeholders. So this way, you can make project-relevant information easily available to all your project members. You can have direct links to different business objects connected to this project, and so on. And just by mentioning the project members under the admin and member tab, you can have a clear and transparent view who is part of this project. So here you can see three participants of this project. And as Codebeamer, everything happens through strict permission control. Here you can see pre-configured roles of the project, and the users can be assigned to one or many roles. Here you can see only one role next to my name, but I can easily drag and drop, and a new role will be added and can be deleted easily just by clicking on it. So this basically this way we can define how and what information these users will have access to and what actions they can make. And now we arrive to the trackers, which is the main business object in Codebeamer. And this is the structure which is representing the real traceability in Codebeamer. The tracker itself is a Codebeamer specific term and is a logical container for work items. For each and every tracker, which you can see here, there's a pre-configured workflow in place. So if I just navigate to the software requirements, which we are going to use today, I can I can check the workflow diagram behind just by selecting this option here. And as you can see, it's a pretty basic workflow, but it can be easily configured here with the customize option. And just to make sure that you are compliant in your development process, you need to have such workflow engine defined. And if I just click on to one single state transition, let's say approve, I can define who can approve this specific requirement, and I can set it based on individual users and based on the roles which have been defined in the system and it connected to the project. So it's pretty easy to specify the permission rights and who's responsible for what. And from here, if I go to the detailed view of my requirement, on the left-hand side, I can see a structure of my software requirements. And in this view, I can easily implement a hierarchy, parent-child and parent-child relations. So, for example, I can specify a folder like this with a simple right click on the requirement. Sorry, new folder, or I can create a new child. And now if I select one of my requirements, we can see that right upon my selection, the content of the requirement is available, which is not pre-filled now, but I can see this its title, and it should be a detailed description here, and you can have tables and images and other different objects added as well. Yes, and on the right-hand side, which is more important, you can see some various different attributes that I can change easily. Let's say the business value, and I can save it. Okay, and we arrived to the traceability and how we can build this up. So it's pretty easy because next to every requirement, there's this plus button here, and based on the underlying configuration, and I am allowed to derive items from one single requirement. Now, if I click on it, I can see all the available items I can derive from this software requirements. So if I would like to derive a test case, I just simply need to click on this item, test cases, and in the window which pops up, in the verifies field, I can see this link back to the original requirement, and I can also set the propagate suspect status, and which is already set up as we can here see this this tab. And it means that whenever I change this software requirement, the suspected link will turn into red, and that is basically a flag or the notification of the system that I might not be consistent in my development process, so I need to check them. So to say, the biggest benefit of having an ALM solution is the full traceability. And if we are going back to the trackers, we can see the whole structure we built, coming from the top, which is the main requirements, the product requirements, going through the hardware requirements, till down the user stories and the tasks. We can define and then build a custom solution as well. And in this project, we have already pre-configured sets in the traceability browser, because we can easily visualize how these items connected to each other. So if I click on this traceability browser here, I can set manually how this browser should look like, or I can use these presets I just mentioned. And here we have this development lifecycle, which is going to show us the connection between the product requirements, the hardware and software requirements, then the user stories, architecture, down to the hardware and software tests. If I click on this, we can see this structure loaded, and each level is reflected here. So in the first level, there's a product requirement which has 7 items. Then the hardware and software requirements, which altogether has 15 requirements. And this is how we visualize the connections between the items. So these product requirements connected to these 2 software requirements, which has also 2 software user stories. And this one software story has many tasks. It's 7 if I count it right. Yeah, and it shows it here as well. And we can see again the suspected links, which is which means wherever you see the suspected option, it's checking the higher level. In this case, this green product requirement status. And if that requirement has been changed ever since you set up this link, then this suspected link will turn into red, and it's a notification again that you might not be consistent. And just by clicking on this link, you can use the side-by-side comparison to decide if you can proceed with the development or not. So if you click on that, you can see the changes. You can apply them or ignore them easily just by clicking on the X, and it's going to turn back into gray. So that was my part in short, and at this point I would like to go back to the trackers overview and hand it over to Matt, who is going to show you the automotive testing function. Thank you.
Thank you, Adam. Okay, so hopefully on my screen you can see something that mirrors that. I've actually got this on a local machine, so you can see here you can do this both in the cloud or locally on your own dedicated server. And this is the same project, but I have got some additional software requirements in here and a couple of other things that are pertinent, one of which is cantata test cases. So I have set up Codebeamer to understand what a cantata test is. It's a very quick configuration. Don't need to show you that. I'll show you the flow of work that's within it. So what we're going to do to start with is to look at these software requirements in the software requirements tracker. And you'll see that these are the ones that Adam was showing you earlier on. I've got one called values check, which has got 3 low-level requirements for some functionality in a source file, which has got a couple of functions in to do values checking. Relatively simple. I want to keep that simplistic in terms of understanding the flow rather than complicated requirements for complicated software. So I have some requirements in Codebeamer. How do I take that and use it inside Cantata? Well, the first thing I do is export it. So I will go to the admin and do an export as a Recif archive. And I will select what I'm going to export, in this case, the software requirements number 5. And I'll click OK. As you can see, that's now downloaded to my downloads file, the Recif file. So in Cantata, I can simply switch over to Cantata. This is the Cantata Eclipse interface. And I have a tab within the Cantata Eclipse interface called Trace, where we do our requirements tracing. Now you'll see here I've got an empty set of requirements just as a space holder to show that you can actually have requirements in lots of formats. What I'm going to do is import the set that I have just exported from Codebeamer. So I will be looking for a Recif style Codebeamer. I will give it a name. Let's call it example demo. And in this case, I'm simply going to select the Recif file that I've just downloaded. And you can see that Cantata has understood that it is section 5 software requirements that are going to be imported. And I'll click OK and create that as a new requirement set on the Cantata server. So, OK. And now in terms of the interface, you can see that the requirements that are all there are imported. And if I expand out, that's the values check set of requirements. And I have abilities to choose a set of these requirements and even store that. So I'm going to choose all of them for values check. I'm going to save that as Matt's work or something like that. I'm going to make it available so the team know that these are these are the requirements I'm working on. So that is now available for other people to see as a selection. This is my particular job, and I have selected that set of requirements. I can also do filtering. If I've got a very long list, I can expand that out, and you can see the different tree levels that you will get reflected from Codebeamer. So I've now got two other panels that I can look at in Trace. The first one is requirement trace, and this is just the selection that I'm now working on. So you can see the values check folder and the three individual requirements below them. If I double click on any of the requirements, it will open up all of the information in that requirement. So if you do have diagrams or tables or hyperlinks or anything else exported from Codebeamer, that is all available to you inside the Kantata interface, which is very helpful when you are looking at the tests. So, tests. I have some code. There's a little project over here, which has got various source files. And what I'm going to do is automatically generate, using that AutoTest I talked about, of those source files. So to do that, I simply take this project, which is an Eclipse project pointing at the source files and header files, and I use the Generate Test Script button. This is going to say, what server location do you want to put this information on? So I will simply choose one called AutoTest Demo. And now I'm prompted to ask what type of tests I would like to generate. And you will see here, it's saying number of scripts. Well, I could have a single integration. No, I want multiple unit tests, and I want to do them by AutoTest. And you can see I've used a coverage rule set. There are many within Kantata, lots including for the different integrity levels. I'm simply using one that is explanatory. So all the entry point statements, call returns, decision outcomes, and MCDC conditions are going to be exercised by the tests I automatically generate. And when I click finish, it starts building them. You will see a Kantata directory being created, and the tests are going to be added as they are being generated. This is the scripts as well as the make files and everything else to run these tests. So this will take a few more seconds, not many, as the Kantata generation is extremely quick. And you can see immediately in the results an AutoTest generation report, which explains what it has generated. It took 19 seconds to generate fully MCDC exercising tests for all of those individual source files. So 5 source files, 5 sets of tests, all exercising up to 100% MCDC coverage. And the longest one only took 5 seconds. I don't want to do too much code in this because it's a demonstration. So what I'm going to look at is what those tests are and load those into the server. So I've created those tests. I should now be able to see on the filter here, the tests have been created. You can see that they are identifying, in this case, the values check one that I'm interested in has got 7 test cases created. But however, in order to look at tracing those tests to the requirements rather than just looking from the test itself, I would prefer to look at the test once it has been exercised, because I don't want a test that doesn't work. So that's what I'm going to do next. I'm simply going to run this set of tests. Now I'm going to show you that Kantata is highly configurable. So I'm going to use a run configuration here, which is all full build, but not of all of the tests. So I'm going to do is a selection of tests, except it hasn't worked out which selection there is yet because it's not been pushed to the server. So we'll run all the tests for now. There are no tests for the project. Has it taken the wrong project? Let's try it again. Run as Kantata test. That's why. Okay, now there's my full build and my set of tests. I'm only going to run the one I'm interested in, values tech, apply and run that. So I can do incremental builds, I can do full builds, the full control that Make gives me. And as you can see, that test fully passed. If I look at the coverage, look at the results details, I can drill down and see all the individual tests. You can see a little summary on the console. And I'm also going to look at the test so that I can see which test cases meet which requirements. So if I go to the test, you can see that there is a source file there. I can open this with the test script manager. For ease of showing on screen, I'm just going to make this a bit smaller down here and look at the test cases list. So these are the list of test cases in that script that have been exercised and all pass. This is where the requirements comes in really handy. Okay, if I refresh that, you should see that all of the tests pass. So they now got decorators showing that they are all passing. And I can look at the individual test cases and map them to requirements. So the first test case is 1 levels. So let's have a look at that one. This is the test case editor in Kantata. How is this going to meet the requirements of these sets of requirements for the code? Well, this one is the default case. The first test case it ever creates is a default using 0 input values. And you can see it's got first pair and second pair input parameters, which are the first and second inputs A and B. a sum of those first and second inputs of A and B, presumably, and they are below the threshold. So the first test case verifies that. Does it return okay? Well, let's just have a check. In terms of the results, the return value is 0, which is okay. Great, first test case nice and easy. Second test case, levels, is over the threshold. Cantata AutoTest tells me why the case was created, greater than 20 for the second pair. So the second test case verifies the second issue where it should be returning a 0, or returning 1. So let's just check, return value equals 1, and you can see in the return value equals 1 for the results. The third test case, very similar, this time for the first pair, not the second pair. So this one also verifies that requirement. Those are the first levels ones. Let's look at the bottom set for values check ones. So there are two functions in this code. The values check test case is created to solve a true case of levels returning at line number 56. Now for this, we can't directly call that piece of code on its own. So we've had to use call interface control. And you can see in here, Cantata has created automatically an instance and a wrapper for the levels function being called from the values check function. So it's like a stub, but it's not, it's a wrapper. And in this case, you can see the information that it is returning back to the code under test is the value 1. And that is why it is expecting the return to be an error. What does all this mean for the code, for the requirements? Well, it means I shall set the share value at this global data result, but I'm also getting this error condition returning. So 7 is definitely returning an error when it's over the threshold. Even though the input values were not, it has controlled the return from the sub function, and therefore the return is a 0. Has it checked the value correctly for the share? Sorry, wrong test case, there you go, 7. Share is the expected share, yes it is. The sum of 0 and 3 is 3. 1 divided by 3 is a third. Test is passed, as I would expect, and therefore this test case is verifying the share. So that share requirement, just make that move up there, is verifying here. So 7 is also testing that requirement. And 6, well, what's 6 doing? 6 is created to solve the case of the total, i.e. the denominator of the A's and B's, of C and D, being non-zero. I can see that information with a different order. You can see a different instance, number 1 in this case, and 1 is returning 0. You can see here. So the 6th case, very simply to check and trace across, is it doing the check as well? Yes, it's also a third. There's the same values being used, and this time the return value is okay. So that test case, very valid, meets the requirements of this one. So now I've got those test cases. Let's look at 5 and 6. Here's 5, created to solve the false case of E equals 0. That doesn't meet any of the requirements. Let's look at 4. This is the default case where all the values are going to be 0, as you can see. All the values input are 0. Return is 1. Therefore, this is not meeting the requirements because I have nothing in here that talks about the defensive programming that must be going on in this code to deal with a divide by 0. Yeah, E divided by the sum of these two would be a divide by 0. It's not crashed the code, it's correctly returning a error message. So I've got 2 bits of software behavior that do not map to a requirement. Let's leave Cantata, go look into Codebeamer. So what I'm going to do is export the information I have got from this straight into Codebeamer. Oop, got an error run. Quite sure why. Let's just rerun the test and show. I think I know why. Hang on. One thing I haven't done is to say I also want to measure the coverage. So what I'm going to do is I'm going to take the coverage gathered by all of this and map it to all of the requirements in values check. And at this point, I'm now going to see if I can export again. I'm still not getting my message running. Demo effect. Let's rerun the test. Okay, that didn't work terribly well. Let me just see if I've got the results running from here. I think it's possibly I might need to make sure that the project is pushed to the server. So let's just do that. Let's go into the Kantata Actions and upload the results to the server. These are the ones that I'm not running. These are the ones that I did run. So the information should all be there. And let's try one more time. Good. Okay. Always helps if you don't forget the steps. So now I have exported the test run that I've got from Kantata directly back into Codebeamer. So in Codebeamer, I can take a look at that. In my tracker, this is my software requirements. And you can see individual requirements are traced to individual requirements are traced to individual Kantata tests. If I go into a Kantata test, you'll see here that particular test passed. There's the run of all of the tests. So if I go to that as a nice summary, and I look at that test run, you will see all of the test cases that have passed. Yep. And you can see the coverage that has been achieved, i.e. 100%. So this is good, but remember I've got additional behavior in the software not captured by a requirement. And this is very common with existing legacy code. I may not have well defined all of those before. So what I'm going to do is go to my requirements, and I'm going to add a couple of requirements to capture that behavior, the behavior that I had from those additional tests. So in this case, I'm simply going to, as we saw before, create a new child. Let's call this one VC4. And the behavior we want to capture in this case will be that first error condition when E is 0. Save that and create another child. And in this case, this will be where the sum of C and D are 0. So let's call this one VC5. And save that. So basically, I now have two new requirements, obviously not traced to any test cases yet, and that's why I will need to export that back to Kantata. So I'll do an export as a recif. Remember, choose my software requirements. Okay. See, my second recif file has now been downloaded, and in Kantata, I can import that again. So this time, I don't want to lose all this work I've done before, so I'm going to copy the assigns that I've used previously and import the new recif file on top of them. So Kantata is amalgamating the information that it had before with the new set of requirements. So you can see here, this is the one I've just imported. I'm now going to compare that to the one that I imported previously. Okay, and you will see that Kantata has identified these as new requirements, highlighted in green, deleted ones in red, and so on. So if I want to, I could just focus on the selected requirements being just the new changed ones. Very helpful if I have lots of requirement variation and versioning. So this is my requirements to trace. You remember these are my two new ones. The test cases that we're verifying or generating those were 4 and 5 for values to check. So I can simply drag and drop those and make the associations. That's great. New requirements for the generated tests. I want to make sure I export back everything, not just a subset. So I'll select the lot. There we go. So now I can see the complete picture, and I can see that there are no test cases left unassigned in my requirements trace. Okay. Each individual ones with all of the necessary requirements are traced, and you can see it bidirectionally, requirements trace or test trace. Okay. So I have all of my requirements traced. I have all of my coverage information there, and all I need to do is export that back to Codebeamer. And in Codebeamer, I'm going to go look at my tracker. I can see my software requirements. I've now got these associated test cases. The associated test cases have got a run, as you can see here. Let's look at the top level one. So we can see all of them. Now gone from 6 up to 8. Everything is passing. I'm getting 100% code coverage. And with the very helpful tracker, so I want to go to the trackers list and then look in the traceability view. And what I'm going to look at here, or for my software requirements, is what traceability I have got with Cantata. I'm going to make sure it is for the software development. And if I then expand the software requirements, you will see that all of the requirements have been verified. The test, the run of test for values check has passed, and all of the requirements are fully covered with passing test cases. Now, in terms of Cantata, of course, I could run that information and see the details of the requirements by going into a Jenkins run and picking the Jenkins run, finding that from here and finding a link. And that would then create me a link from here. Did I actually run that? There we go, build now. There you go, running a build. So I can create a link to that information online on the server from Cantata or from the Jenkins run, but I can also see exactly the same information for the test run. So I can see that if I look at an individual test in Cantata. So if I just go for the Cantata trackers, there's the test cases. There's the run. Test run, that's what I was looking for. Test run is test runs. I want to go to the test run tracker, of course. So this is the test run tracker. That's where it all passed. And if I look at the individual tests set up for those, for any individual one of those, I can see the results for that set of tests by going directly onto the Cantata team reporting interface, which shows me all of the results, coverage, which I can explore exactly like I saw in the Cantata Eclipse interface. I can explore the coverage. I can look at all of the coverage that I've obtained in terms of metrics, as well as looking at the source files. As well as looking at the source files with all of the color highlighted code that has been exercised, and as well as the coverage and the test results, I have all the associated files, including the tests themselves and the source file that has been tested. So I have every resource that I need, all the automatically generated tests and summaries and aggregates and information, including where the test was run and all the additional information that Cantata team reporting can store for you. Okay. I think that concludes my part of the demonstration. Christoph, can I pass you back for handling the questions?
Absolutely, thank you. So we already have 2 questions, but now is the time for everyone to please use the questions box. Just type in your questions and we'll just go through them. The user was asking, what is the maximum complexity of code supported by the auto-generation feature? What are the limitations?
So thank you for the question. There are some limitations. When I mentioned that there were some things that we can identify as testability problems within the Cantata AutoTest function, there are. So if there is unreachable code, Cantata cannot generate test cases for unreachable code, but it can also identify test crashing scenarios, which would cause your tests as a set of tests to stop working, and therefore it does not automatically create those tests. In the Cantata interface, what you'll see the team, this particular AutoTest generation report that I had before, you will also identify anything that even if the test works may be a problem. So for example, uninitialized variables. So sometimes things like statically defined local variables within a local function can prevent the tool from auto-generating 100% MCDC coverage. But that's about the limit. It's an incredibly powerful test vector generation. So the scale of the code does not matter. The complexity of the code does not matter. You can have nested loops and if defines and all sorts of things inside that code. There are a few edge conditions like local variables inside locally defined functions that declared static, so not file scope, but function scope. That can cause an issue with Cantata generation. But even if it doesn't generate 100% of all the test cases, and it only generates 99%. That's a heck of a lot faster than doing them manually.
Matt, the same user is asking whether we can see the code related to the auto-generated test cases. I'm not sure if that's
absolutely.
relevant.
The graphical view of the Cantata test because it was a bit easier to see it. So you can see here the values that were being used, but inside the Cantata interface, you can not only see them graphically, but also in the source code. So this is a synchronized editor view of the test cases, and you can see all of the information that is generated. And you can see that it basically looks like C or C++ code. Here, the test case data declarations are setting a value for this particular static piece of data, which is why you'll see an access variable before it, which is a call to Cantata to say you can read this private protected data and set it. And it does that through its instrumentation. And all of this code is perfectly visible directly alongside this one. So if I change anything in one of these, like I want to change the name of this test to Matt instead and save it there, you'll see that it immediately gets reflected in the graphical editor.
So another question we're having is about content AutoTests, whether they are easily editable even when they do not match requirements.
Yes, the test editing is very simple here. The power of the requirements traceability, and the reason that we spend so much time and effort making good integrations with tools like Codebeamer is because the tool is auto-generating the test cases from the code. For the safety critical standards, you need requirements-based tests. What it doesn't say is that you have to use pure brain power to define what the test case input vectors are themselves. So you could, for example, go into the Cantata tool, select a test case. I want to define the test case values myself, like with a table-driven test, and define individual values for individual functions using things like ranges and stuff like that. Or you can have, 10 to 20, 10 to 20 with the delta of 3, and that will produce you the thing on the end. That will produce you 4 test cases. You might just have the number 2 in the second one. You might have the number 4 in the next one, and so on and so on. So you will end up with a combination of test cases, or this is the hard way of doing it, or you can use AutoTest, which will generate all of those combinations of values for you to derive the software down all the parts. But as I come back to it, the reason that we do all of this requirements tracing is because you can show that the test cases that are auto-generated for you, like these values here, and as you'll see, is generating right on the boundary, so very good for boundary value analysis, are then mapped to requirements. They fulfill the requirements. Behavior, so checking the return value and so on.
There's another one actually relevant here. Can you specify how Cantata generates the code in terms of folder structure, for example?
So in terms of generating the code, the first thing is Cantata, you'll see is everything under the Cantata directory is all the Cantata stuff. There is one file that sits outside the Cantata, information, and this is called our ipg.conf file. It's basically the options file that says use Cantata. Yep. So if this is not enabled and we're not using Cantata, you can simply rebuild your code directly. So I could do a release build, for example, as opposed to a Cantata test executable build. So everything is contained inside Cantata. The configuration contains all the make files. Results are stored in one location, so you can see all the different summary results files, test reports, things of that nature. And then the tests are grouped as a set of tests, and each individual test then has the test script, associated results files, and make files. All stored logically on the file system under where your code is, so that it doesn't have to, you don't have to sandbox your code into a certain location to do that. Of course, you can rebuild and run that directly off the Jenkins build job, check an entire code branch, generates the Cantata tests, and you can dispose of them or check them in as you wish. For certification evidence, Cantata produces one particular file, which is this one called CTR file. Sorry. Press F5 to refresh. There you go. There's the CTR file, and this is the ugly, not very pretty view Cantata results. As you can see, with all the straight text and identifying individual things like the A or B parts of the expression and how effective they were for ECDC. So this is the evidence you need for certification right up to the highest level. All of the results I've been showing you in these nice graphical views are basically helping you diagnose, does the test do what I expect it to do? This is your evidence for the certification authority. It doesn't have to be pretty. Yeah, these ones do. The reports you give to your manager, yeah, whether that's a report in GJB report format for Chinese, or it's a simple overview report for your manager on which tests have passed and which coverage was achieved. This one over here, that's the certification evidence. All of this, remember, runs on host or on target. So all these tests are created platform independent to be executed on a host or a target platform.
Matt, there's actually a question from the same user. Is it possible to change the folder structure? Can I change how I want the folder structure? That's how the question goes.
Is it possible to change the Cantata folder structure itself or where the tests are located? Because you can't change Cantata configuration results tests, but you can change where the code is. So if you don't want to have Cantata directly over your code, then of course you can create a project that references where your code and your header files and things are. So I might have a hierarchy of header file structures, a hierarchy of code files. They may not be directly in this project. They may be simply referencing the files. This is an Eclipse interface, so we have all the capability of referencing files in whatever structure you want to have them to build and run Cantata tests. This is just a simply easy way of showing you for the demonstration that all the code is flat, it's nice and simple to see, and the Cantata structure is simply sitting completely alongside the code, not messing up your ability to build your own code.
We actually have a new question about the code, whether the code we have seen was instrumented by Cantata or was it the raw code?
The code was instrumented by Cantata. The reason that that occurs is, and if I go into the values check, you will see, no, you won't, because it disposes of them. The behavior of Cantata is that it will do an instrumentation. It will effectively add two things or two types of things to code. One, probes, so we can measure the statement counts and things like that. And secondly, the ability to make the test itself visible for, to make the code visible for testing. So for white box testing, Cantata, if I just go into C++ editor again for the script, you'll see these things like access variables. This is part of the instrumentation of Cantata to say, okay, this information, yeah, the first pair and second pair, if I actually open the code in the project, you'll see, values check, there you go. These are static doubles, first pair and second pair. They are not accessible to a test normally outside of this source file, but they are to Cantata automatically because Cantata has instrumented them to say it can access them. This instrumented file is disposed of, which is why it's no longer here, because we generate this on the fly, dispose of it. So in short, we take a copy of the production code, instrument it for testability or to measure it, and then dispose of that intermediate file, leaving only the production code that is tested with the results that prove it.
I think
and as Christoph mentioned, if you have more questions, we would be delighted for you to email them to us afterwards and be happy to pick those up and provide you comprehensive information in terms of a response, or even arrange a more detailed demonstration of what Cantata and AutoTest does for you. One thing I will say is that there is a whole web page on the Cantata site dedicated to AutoTest, with video demonstrations and explanations of what it does and how it works.
I was just going to say that it's probably, I'm sorry.
On the requirements page, we will also have a video uploaded in a day or two's time of the Codebeamer integration with Cantata. And you'll see how that works if you want to drill down and look at it in more. There would also be a technical note on showing exactly how you do the bit I said in here, where you are setting up. That Codebeamer knows what a Cantata test is. Very simple, 10 minutes. Literally, there's a technical note that explains how you do that too. And that's for setting up what this is. So thank you very much for your questions. They were really interesting. As I said, loads and loads of resources available on our site as well. If you do go to qasystems.com and you look under the tools Cantata, you'll see all the information there, not only about AutoTest, but also about the requirements, traceability, and integration with the different tools like Codebeamer. So that's the Codebeamer one, and how it works, and all the traceability information you get, like the filtering between changes for variants and version management of requirements too. Okay.
All right, Matt, thanks a lot for the demonstration. Also, Adam, thank you. And thanks everyone for your attention. We're a little bit over time, so it's time for us to stop today's webinar. But if you have any questions, as Matt said, please feel free to get in touch with either QA Systems or Inland Software, and we'll do our best to answer all your questions. All right, so thanks a lot for your attention, and goodbye.
Thank you. Bye-bye, everybody.